Hi there. In this video, I will talk about the Tableau internal machine algorithm linear regression. And as you can see, the objective of linear regression is to fit the best line by minimizing the errors. So here we have one example where we have age on x-axis and we have salary on y-axis. And as you can see, this is basically indicating that age is increasing. And if you see the salary, the y-axis, you will see that salary is also increasing. So that's a simple example I wanted to show you to give you an example of linear regression. So idea behind linear regression, or the assumption, is that the two variables of our interest for which we want to do the prediction, they should be linearly correlated. Now in this case, you can see they are positively linearly correlated. There may be scenarios where they are negatively linearly correlated. So if that assumption is met, then we can go ahead and fit the linear regression. So to fit the linear regression, we can use Tableau internal machine learning algorithm. And so what I'll do is I'll go to Tableau. Here, let me open the Tableau, and what I have is, as a sample data set, is this Boston housing data set. What it has is the price information in thousands of dollars for the different apartments based on the these parameters, like the crime rate in that locality, the number of rooms per dwelling, the age group in that locality, and tax and PT ratio. So different parameters that we have. So what our objective is to predict the price based on these different parameters. So what we can do is, say, average number of rooms are pretty good idea about what the price should be. Generally we look at, whenever we go and look for any apartment, we see number of rooms and then see whether the rent or the price of the entire apartment making sense or not. So we will take these two variables and see whether we can fit the linear regression. Alright, so here I have the Tableau. I will click on the text file and I will put the Boston dataset over here. And this is the Boston dataset, the same one which I showed you over here. Once it is there, I will go into the sheet. And once I am here in the sheet, what I can do is I can take the RM, which is average number of rooms per dwelling. So I can put it in the columns. So we don't need the sum, but what we need is the dimension. And then what we have is the price. I will put the price here. And what I'll do is change the visualization to the linear. And if you see, as the average number of rooms are increasing, the prices are fluctuating and giving us an indication that it is increasing linearly. So to fit the linear regression over here, we need to go into Analytics tab. And here we have the trend line, which will basically fit these data points by minimizing the error. So I will just take it and put it over here on the linear. As you can see, you have other algorithms like logarithmic, exponential, polynomial. So what I'll do is I will put it on linear for now. So now this linear regression line is fit, and if I hover my mouse over to the line, you will see this equation which saying price is equals to 9.15176 multiplied with RM. That means as the number of rooms are increasing, it will be multiplied with the 9 as it has identified it as a slope of the line, plus minus 32.0593 is basically an intercept, which is indicating if average number of rooms are constant, then whether the price will continuously increase or decrease. So in this case, it is saying it is relatively decreasing. So with the help of this equation, you can basically find the based on the number of rooms, you can find the price. Then also you have R squared value, which is saying 0.29. That means with the help of this average number of rooms variable, you can only explain 30% of this data. Now this value is not good, because R square value, which is somewhere around 80, 85% or 90%, that means whatever error that it has identified, it can explain that error at least by 80%. Right now it is explaining the error only by 29.5%. So our model is better, or the linear regression model is better, if R square is value is high, which indicates that it can explain the error in this with the help of this model. And the p-value is indicating that whether this variable is significant or not. So in this case the value is less than 0.05, and that's the threshold you really need to remember, that if the value is less than 0.05, then you will accept this, otherwise you will reject this. After fitting the trend line, what I can do is add the reference band to get a confidence interval, because whenever we are predicting, giving just the actual prediction value does not help, because there is an error. So what we really need to do, provide the upper boundary and lower boundary about how much it can variate. So what I can do is right click over here and click on the edit trend line, and here I have the show confidence bands, and I'll click OK. Apart from these confidence bands, what you can do is, when you are here on the line, you can right click and you can even click on describe trend line, and this will basically give you the equation, the p-value of overall model, and then the RM variable, the intercept, and then again the p-value for both these one. You can even copy and paste it in some presentation if you want. The last piece is describing the trend model, and here you will see the different labels like model formula, number of model observation, fitted observation, number of filtered observation, model degrees of freedom, all of those statistical parameters of your need, as well as the same similar type of statistic we saw in the previous screen, which was a bit small, but here it's pretty extended, like sum of squared error, which is also called explained error, the mean squared error, which basically helps in calculating whether this model is performing good or not. That means the average error in the model. Then by adding or removing variables, you will see the value will go up or down. So lower the value will be, the better the model is. That's kind of a nutshell the idea is. So you can also, if you are really interested in the statistic, then you can also use the statistic as part of your presentation and put it. So that's pretty much about it, about how you can create a straightforward linear regression model into the Tableau, and fit a line, get a formula, as well as the confidence band, just to see at a 95 degrees of 95% degrees confidence interval what the band will be. But as you could see, this is not where this process ends, because this is a pretty exploratory process where we look at different variables. So far we have looked at only the RM, but in the future videos I will show you how we can even look at multiple variables, and on that statistic, the R squared, how we can really increase it to a respectable level so that you are able to get the better model with the lower mean squared error. So those are the two parameters. R squared should be good, somewhere around 80 or 90%, and the mean squared error, MSE, should be less for your model, and that can be compared by adding more variables.